And we're going to highlight, find where it says completing the square. This is the technique that you guys just figured out. If you had something like x squared plus 6x equals 16. Do you have this? No, you have 3x squared. No, you have it right here, at the bottom of page 202. The way the textbook goes about this, oh, you don't have the algebra tiles. We're not going to do the algebra tiles. No, I want to get the same one here. This is what you have in your textbook, right? This is on page 202. Can you see this at the bottom of page 202? Okay. So you start off with something like this, x squared plus 6x plus 9. You guys were already jumping from here to here. You recognize the x squared plus 6x is the same kind of idea as x plus 3 squared, but then there would have been an extra 9 here. What we're going to do for us is we're going to say, well, if there's an extra 9 here, I'm going to add an extra 9 to that side.
How'd you get the extra 9?
Well, if I have a 6x, this has to be a 3. And if that's a 3, there should have been a 9 there to make it equal. Okay? So this is what it's going to look like for a question for us. Let's just do a separate one. Let's do one that we did. Let's do plus 12x. Okay? And let's say it's equal to 1. And we want to solve this. You know with this that it has to be x plus 6 squared. But if I do x plus 6 squared, and I think, well, that would mean there would have been an extra number right there. And this is the work we're going to show. What number would have been in there if I have x plus 6 squared on this side? Plus 36. But if you do plus 36 on one side of an equation, what will I have to do on the other side so it stays equal? I'll have to add 36 on that side. And so this equation here, what's going to be on this side? 37. Does that make sense? So as soon as I see this 12x, by the patterns we were starting to notice, you know that in here has to be a 6. And then that 6 tells you that here would have had to have been a 36 in order for that to work. And if I add 36 to this side to make it work, I need to add 36 to the other side. What we've done is we've taken something, the x squared plus 12x, and we've changed it to a perfect square. That's why this technique is called completing the square. Because x squared plus 12x by itself is not a perfect square. It needs the plus 36 in order for you to be able to factor it perfectly like that. So we add the 36 so that we can do that, but then I need to add the 36 on the other side. How does that help us? Well, once we have something as a perfect square, we can get rid of the square by square rooting. And so we can solve this one now by square rooting both sides. And you get two answers. One of them will be negative 6 plus the square root of 37, and the other one would be negative 6 minus the square root of 37. So when we go to example 2, to solve this, we have x squared plus 4x minus 3 equals 0. One of the things that we're going to do is we're going to have our x squared and our 4x on one side. We're going to leave a space here. We're going to move the 3 by adding 3 to both sides, and then we're going to put a space here. Because right now, x squared plus 4x isn't a perfect square. If it was a perfect square, you would know inside here would be x plus 2. That's the only way to get the 4x, right? But if this is a plus 2, what has to go in that green space to make it equal? I'd have to have a plus 4 there. If I had a plus 4 on this side, what do I have to do on this side? In order to keep my equation equal, I would need to add 4 on that side as well. So now I get x plus 2 squared is equal to 7. The reason we do this is because we get an equation, x squared plus 4x minus 3. No matter how hard you try, you cannot factor that. And because you can't factor it, if you do this method, you can at least square root both sides, and then you could get x by itself. Okay, so now try questions 5, 8, and 9.